Hi guys, welcome back to Medicopharma Lecture once again. Today we are going to start with a series of lectures on Pharmaceutical Inorganic Chemistry. Okay, so the first lecture we will start with impurity. Okay, note that these all lectures will be available in Hindi as well as in English. Okay, so suppose there is a substance called chemical substance A. Okay, so this is the chemical substance A in which there is another chemical substance B or anything. Okay, let it be anything which is mixed with chemical substance A. Okay, so this chemical substance B will act as impurity for chemical substance A. It means chemical substance B is impurity for chemical substance A. Understood? So now we will define impurity. Okay, so whatever we have understood we are going to write the same. Okay, so any foreign material or substance present in a chemical substance is called as impurity. Okay, so the same thing we have just discussed. Okay, now we will see few examples of impurities, okay, which are present in our pharmaceutical preparations, which are generally present in our pharmaceutical preparations. Okay, so the examples are arsenic. As is the symbol for arsenic. Then lead, plumbus, Pb, that is heavy metals. Okay, iron, that is ferrous or ferric, Fe. Then we have chloride or chlorine, Cl minus. Then sulfate, SO4 minus minus. Then we have fluorine, F minus or F. Okay, so these are all impurities which might be present in pharmaceutical preparation. Now we will see the classification of impurities based upon its toxicity. Okay, so impurities are basically classified into three groups based upon their toxicity. Okay, so the first class is toxic or harmful impurities. Okay, then second one is cumulative, cumulative impurities. Okay, so this is moderate type of impurities. I mean, they will show moderate type of toxicity. Then the last one is harmless or non-toxic impurities. Okay, which may be non-toxic but they can cause lots of problem in pharmaceutical preparations if they are available in high quantity. Now we will see toxic or harmful impurity. So they are very harmful to our body or us. Okay, so second point, they can cause death even if taken once on short period of time. It means they are very lethal. Okay, okay. The third point is immediate toxicity can be seen. Immediate means if you will take now, the toxicity will start now only. Okay, or within few hours. Then they are injurious to health even in a small quantity. Okay, now very low permissible limit is allowed in pharmaceutical preparation. It means very small quantity of these toxic impurities are allowed in pharmaceutical preparation as per pharmacopoeia. Okay, example for toxic or harmful impurities are arsenic and lead, plumbus, Pb. Okay, now we will see cumulative impurities. Okay, so may not cause immediate adverse effect. So if you are going to take today, if you are going to take today, it does not mean you will see the effect today itself. Okay, so effect may be seen after few weeks or few months, okay, or even few years. So when taken for long period of time may shows toxicity. Are you getting? So slowly it will get accumulate and can cause toxicity. Okay, have more permissible limit than toxic impurity because they are little bit milder or moderate than harmful toxicity. That is why they are present in little bit large quantity. Okay. Now examples are iron or heavy metals. These are the examples of cumulative impurities. Now we'll see the harmless or non-toxic impurity. So may be harmless, but its presence in large quantity, if they are present in large quantity, may reduce the therapeutic effect of a drug. It means it may decrease the pharmacological actions of the drug or may cause some other effects. It can cause technical problems during the formulation of a medicine. It means it may interact with various additives of the formulation and cause some technical issues. Okay. The next point is it can change odor or taste of a drug or medicine. This is because it may have its own odor and taste which can interfere with the taste and odor of a medicine. Next one point is it may lower shelf life of a drug by causing the drug decomposition. Okay, so it may start a drug decomposition process due to which it may lowers the life of a drug. Okay, that is shelf life of a drug. Examples are chlorine and sulfate. Okay, this is all about harmless or non-toxic impurity. Okay, with this the classification of impurities is over. Okay, now we are going to see the sources of impurity. It means already you know that what are impurity. So from where this impurity can come and mix with our formulation or our drug is nothing but source of impurities. Okay, so we can define it as any foreign substance. Okay, any foreign substance present in a chemical compound are called as impurities okay, or impurity, and the source from where they have contaminated are called as sources of impurities, are collectively called as sources of impurity. It means from where these impurities are coming, those all sources are called as source of impurities. Now we will summarize these sources of impurities in 5 groups. Okay, so the first group is raw material used in manufacturing process. Okay, raw material used in manufacturing process, so from there it can come. Second point is impurities from manufacturing process. The first one is raw material. Now this one is manufacturing process itself can act as a source of impurities. The third one is atmospheric impurities, okay, like carbon dioxide or air dust or any other things. Okay, next point is storage. Okay, so last one is deliberately adulterated. Okay, so we are going to see individual point in details. Okay, so the first point is raw material used in manufacturing process. Okay, as we know that the manufacturing of any pharmaceutical preparation starts with raw material. Okay, so if raw material contain impurity, the final product will also have the same impurity. Are you getting? So if the starting material is impure, so the same impurity will reach out to the final product. Okay, there are various examples, but we are going to take one simple example. Okay, that is sodium chloride, NaCl. Okay, so you have to write that symbol also. Sodium chloride obtained from rock salt may contain calcium, and potassium as impurities. Understood? Okay. Now we will go to the second point, that is impurities from manufacturing process. So suppose we are using a raw material which is completely free from impurities, still there is a chance of getting impurities in the final product. Okay, so they may come from manufacturing process, as for example reaction vessel, solvent used, reagents, catalyst used, intermediate produced, they all may contribute to the impurities in the final product. Okay, now we will see them one by one. So first of all we are going to discuss about reaction vessels. Okay, so reaction vessels are the instruments in which chemical reactions are carried out. So if they contain impurities, or if they are contributing impurities to the reaction, okay, so the same impurities can be found in the final product. Okay, as for example, galvanized iron vessel may cause impurities like zinc to the final product, okay. Another example is the vessel made up of copper and lead may results into metallic impurities, okay. Now we'll discuss about solvent. Okay, so we know that solvents are used for all the manufacturing process. So if the solvent is having impurities, same impurities goes to the final product. As for example, tap water contain impurities like chloride, sulfate, SO4 minus minus, calcium, Ca plus, magnesium, etc. So water is a universal solvent which is used widely in the pharmaceutical preparations, so we should use pure water. Okay, alcohol may be present in streptomycin as impurities. Okay, why? Because alcohol is used as solvent in streptomycin preparation. Okay, now we will discuss about reagents. Okay, so whatever unreacted reagents will be there in the reaction vessels, they may work as a or act as a impurities. Okay, as for example, calcium gluconate and calcium lactate contain glucose as impurities. The reaction can be shown as follow. Okay, so glucose, it will change into gluconic acid, which will change into calcium gluconate, which is our final product. Okay, here there will be calcium chloride, and in this step there will be nascent oxygen. Okay, understood. Now we'll discuss about catalyst. So catalysts are used to increase or decrease the speed of a reaction. Okay, so these catalysts if they are not removed, okay, from final product, then they will behave as a impurities. Okay, as for example, nickel and potassium catalyst may be present as impurities in carbenzylene sodium. Okay, so carbenzylene sodium is our final product in which we are going to use nickel and potassium as a catalyst during its preparation. Okay, now we will discuss about intermediates. So what are intermediates? Intermediates means reaction intermediates which are formed during the reaction, okay, especially in complex reaction. So while preparing potassium iodide Ki, potassium iodate KiO3 is formed as intermediate, and that may act as a impurities, okay, in potassium iodide. So we have a reaction here, okay. So 6 KOH plus 3 iodine I2 will give 5 Ki plus KiO3 plus 3H2O. Okay, so you should write the name also, like potassium hydroxide, here iodine, this is potassium iodide, this is potassium iodate, and that is the water. Okay, so don't leave these names, okay, word name, otherwise your marks will be reduced. Now KiO3, this potassium iodate will react with 3 carbon and make potassium iodide and 3 carbon monoxide molecules. Okay, now we will see some physical parameters, okay, which are going to affect the final product or may lead to or may contribute impurities to the final product. Excess heating or boiling or applying excess pressure or unequal mixing, okay, if you are not mixing properly, then that will lead to impurities in the final product. Okay, so there are certain examples like conversion of zinc into zinc oxide. Okay, so the reaction can be written as zinc plus oxygen, it will give zinc oxide. Okay, so we'll balance it, here 2, here also 2. Okay, now we are going to apply heat and we are going to write the name, we'll get this type of reaction. Okay, so now third one is atmospheric pressure. Okay, so carbon dioxide, oxygen, hydrogen and dust, moisture and microorganism present in atmosphere can cause impurities. Okay, as for example, sodium hydroxide absorb carbon dioxide from the atmosphere, okay, and it will make sodium bicarbonate. So we can write the reaction as this is NaOH plus CO2, it will give NaHCO3. Okay, so we should write the name, that is sodium hydroxide in the word, this is carbon dioxide, okay, and this is sodium bicarbonate. Okay, now the next one is storage condition. So as we know that if we are storing the final product, okay, whether we have prepared suppose 100% pure final product, but upon storage, if proper care has not been taken, then it may cause various types of impurities. Okay, so poor storage condition causes impurities. As for example, ferrous is oxidized to ferric in presence of oxygen upon storage. Understood? So suppose we have ferrous containing final product, okay, which will oxidize to ferric, okay, in presence of oxygen. So the reaction can be written as Fe plus 2, that is ferrous will change into Fe+3, that is ferric. So we can write their name also in the word, and we should write nascent oxygen here. Are you getting? Now another example is silver salts are decomposed by light. Okay, so whenever silver salts containing final products we should store in ambered color bottle, okay, or where light will not reach out, otherwise it may cause impurities. Now the last one is deliberately adulterated. Okay, so expensive drugs are adulterated with cheap drugs or low quality drugs. So why this is? This is because we want more profit, or someone want profit, or it may be happening mistakenly, or due to the scarcity of the original drug we are going to use some substituent drugs. Okay, as for example, potassium bromide is costly and is adulterated with sodium bromide, which is cheaper. Okay, so this type of things can be done for getting more profit also, but we should take care of the therapeutic values as well as. So if we are doing the adulteration by means deliberately adulteration is done, then it may lead to decrease in therapeutic value as well. Okay, with this we came to the end of this lecture. Okay, so for note you can join our WhatsApp group. The descriptions and links are given below in the description section of this video, and thank you very much for watching us. Kindly subscribe our channel. We are going to come with more lectures on pharmaceutical inorganic chemistry, as well as I will try to touch other subjects. Okay, thank you very much, and best of luck for your study.